Welcome to BTEC Revision. In today's lesson, we're looking at vector addition of phasors. And by the end, we should be able to calculate vector addition of sinusoidal waveforms. How do we add sinusoidal waveforms? The standard form for a sinusoidal phasor is as follows. V equals capital V sine, in brackets, omega t plus phi, close bracket. A phasor is a mathematical representation of a sinusoidal waveform. Looking at these values, lowercase v here represents the current voltage. Capital V here stands for the maximum voltage. Omega is the angular frequency. And time is represented by T. And phi is the phase. The units for voltage is volts. Angular frequency is measured in hertz, which is also equal to 1 over seconds. Time is measured in seconds. And phase is measured in radians or degrees. Now consider the following phasors. V1 equals 10 sine omega t, and V2 equals 15 sine omega t minus pi over 2. We are able to add these sinusoidal phasors if they have the same frequency, and in this case they do. Let's look at the graphical representation of these phasors. Here we have V1, which has a size of 10, and we can represent that with this line drawn here. V2 has a size of 15, and that's represented by this line at this angle. The first phasor is drawn at the horizontal, which is representing zero phase. The second phasor is drawn at an angle of pi over 2 or 45 degrees, going down because it's negative. If it was positive, then we would draw the line going up. In order to add these, we can draw a parallelogram. And then we can draw the resultant voltage. Since the parallelogram has the same length, we can label that 15 on the right and 10 at the bottom there. And if we remember, we have a non-right angle triangle. And in order to add the lengths or work out the lengths and angles, we can use the cosine rule, which is stating a squared equals b squared plus c squared minus 2bc cos a. Looking at the trigonometry for a parallelogram, this angle must also be 45 degrees. Therefore, in order to work out angle over here, the A angle, in order to use cosine rule, we can do 180, take away 45, which gives us an angle of 135 degrees. The reason why we work this out is because this is our A value, which we need in order to work out our VR. Now, using this rule, we can plug in all the values. So VR is our A in this case. Our B, we can choose either one, but we'll stick with 10. So that's 10 squared plus C, and that's our C value here. So that's 15 squared minus 2BC, so that's 2 times 10 times 15, and then cos A, 135 degrees, and that's degrees, and that gives us a value of 537.1, and if we square root our answer, that gives us VR is equal to 23.2 volts. And if you remember, sine rule is sine A divided by A equals sine B divided by B. Rearranging for sine A, that sine A equals A sine B divided by B, which is 15 times sine B, which is 135 degrees, divided by our b value, which we worked out to be 23.2. And this gives us a value of 0.457. So taking the inverse sine of our answer gives us 27.2 degrees. And to convert this into radians, we can do times pi divided by 180, which gives us a value in radians of 0.475 radians. So therefore, we can write the phasor. So VR is equal to the value 23.2 times sine omega t, and that would be minus 0.475, and that would be in radians. You can also work this out using scale drawings. So we can use a ruler to work out the lengths and a protractor to work out the angles. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com. See you